In this video, we're going to continue our discussion on Chapter 2 by looking at what we call levels of measurement. Now, levels of measurement really refer to the quality of the data that we're collecting. So we call them levels of measurement. We also I will refer to them as scales of measurement. So whatever scale of measurement or level of measurement that data is recorded with, that's going to determine the quality of it, all right? Really, what can we do with it? What can't we do with it? All right, so there are 4 levels of measurement. All right, those levels are nominal, ordinal, interval, and ratio. All right, so these are the 4 levels of measurement, and as we go down this list, right, the quality of the data goes up. Right, so nominal level data or nominal scale data, this is the lowest quality data, right? We can't do as much with it as we can any of the other ones. All right, ratio level data or ratio scale data, this is data that we can do pretty much anything with, right? Or at least anything we can do in statistics, we can do it if we have ratio data. It is the most useful, it's the highest quality because we can do a lot of different things with it. All right, so these are in order from most, or kind of the lowest quality to the highest quality, right? Which is kind of nice because it forms a acronym or an acrostic, you could say, right, of noir. Right, and if we use this, if we like mnemonic devices or things of that nature, right, we can use this to help us, one, remember the order they're supposed to be in, right, and also to just jog our memory of which ones there are, right, which levels of measurement there are. Right, this can also come into play when we are looking to determine which type, which scale of measurement, which level of measurement some data uses, but we'll get to that in a little while. So let's start going through these individually. All right, we're going to start with nominal since that is the first one. One more thing before I actually start doing this. So these build on each other. So anything that say nominal scale data has, ordinal scale data will have that and something else, right? Anything that ordinal data has that will also be had by interval scale data and something else, so on and so forth. I'll be pointing that out, but just a heads up, all right? But nominal scale data is the first type, right? This is data that can be placed into distinct groups and categories. Alright, so our data can be placed into distinct groups and categories, and that's really all we can do with nominal scale data. It doesn't provide us a ton of information, right? It's really just kind of a label, a descriptor, and that's it, right? Some examples of nominal scale data. All right, just a couple. All right, this is by no means an exhaustive list, but something like race, a person's race or ethnicity, right? That would be nominal level data, right? Gender, a person's gender would be nominal scale data. Profession, all right, again, that would be nominal scale data, all right? So with something like race, right, we could kind of put people into broad categories of race, right? White/Caucasian, African American, Asian, so on, Asian American, so on and so forth, right? We can put people broadly into those categories, but again, that's all we can do, right? That's all we can really do with this nominal data. One of the features of ordinal data, right, this is the extra thing that ordinal data has on top of nominal data, is that we can logically rank or order our data, right? We can't do that with nominal scale data, right? There's no logical order, there's no way for us to put a person's race in order, because no race is racier than any other, right? Same with gender, right? No gender is more gendery, right, than any other. There's no way to put those in an order, right? We're just grouping and categorizing. All right, so for ordinal scale data, all right, this data can be placed into distinct groups just like nominal data. Right, and as we already mentioned, it can be logically ordered, right? So it's got the same properties as the preceding level of measurement, right? But then it has something unique to itself, right? So ordinal scale data can be placed into distinct groups and categories. It can also be logically ordered. Right, one of my, probably one of the best examples of this is something known as a Likert scale. Right, so you might not know, you might not be familiar with this term, but I guarantee that you have at least seen a Likert scale at some point in your life. A Likert scale is one of those things you often see them in surveys where it will say, to what level do you agree with the following statement? 1 through 5, 1 being strongly disagree, 5 being strongly agree, or some variation of that. All right, so that's a Likert scale. All right, and that would be an example of ordinal scale data. All right, when we have data like this, all right, we can put it into distinct groups and categories. This person said 2, this person said 3, this person said 5, so on and so forth. And we can logically order it, right? Somebody that says 5 agrees more strongly with the statement than somebody that says 2, right? So we can put those into a logical order, right? But that is all we can do with this type of data, all right? The next step, and we're just going to have to keep previewing the next scales just because that's the way these they work by comparison, right? So when we compare ordinal scale data to the next level of measurement, which is interval scale, right? Interval scale data is different because it has fixed units of measure, right, between data values, right? So what that means is that kind of a 1 unit increase, right, for interval scale data is the same no matter where kind of on that scale you find yourself. Right, that is not the case with ordinal scale data, all right? So for example, all right, so let's say that this is our Likert scale, right? So 1, strongly disagree, probably somewhat disagree, neutral, somewhat agree, strongly agree, 1 through 5, right? So when we're looking at a Likert scale, or really any ordinal data, the difference between 1 and 2 is not necessarily the same as, say, the difference between 3 and 4. All right. There's a different amount of convincing, perhaps. So let's say this is kind of some argument or like trying to persuade somebody to increase their level of agreement on whatever statement we've made. Right? There's probably a different level of persuasion needed to get somebody to go from 1 to 2 than there is to get somebody to go from 3 to 4. Right? Those are not fixed. They are not. These 1 unit measures are not standardized. Right? These we can't really do math with. Right? Or not. It's not that we can't really do math with it. We can't do math with it. Now, a lot of people will do math with these, but you're not supposed to. All right. So, for example, if we were to say, let's say that one person said 5. Like they were answering this question, they said, I strongly agree with this question, right? And somebody else said, I somewhat disagree. So they said 2. Right? If we had these fixed units of measure, right, then we could tell the difference between the first person and the second person by doing subtraction. All right. So if we were to say a 5 minus a 2, that's a 3. There's a difference of a 3. All right. And that's what a lot of people will do when they are dealing with this stuff. All right. However, these numbers aren't real. They're just placeholders, right? What they're actually representing is this level of agreement. Right, what you're actually trying to do in that situation is strongly agree minus somewhat disagree equals neutral, right? That doesn't make sense, right? We cannot do math with kind of the data from these Likert scales, right? Or any other ordinal data, right? Any other ordinal scale data, right, is not appropriate for kind of mathematics, which we're going to talk about briefly in a second again. But again, we don't have those fixed units of measure. So we can't do math. All right, so that is ordinal data. All right, the next is interval scale data. All right, so interval scale data has the same properties as ordinal scale data. We can put it into distinct groups and categories. We can also logically order it, right? But it also has those fixed units of measure. Right, so kind of a fuller definition, right? Same properties as ordinal scale data and a meaningful interval between data expressed in terms of a fixed unit of measure. Right, so the 1 unit changes are going to be the same whether we're kind of, if we're picturing a number line, I guess, right? Whether we're way down in the negatives or way up in the positives, right? The magnitude doesn't matter, right? A 1 unit change is a 1 unit change for interval scale data. All right, there's not a whole lot of examples, or at least not common examples of interval scale data. One of the best ones though is temperature, right? So really temperature when we are dealing with it in either the Fahrenheit or Celsius scales. So temperature in, we'll just stick with Fahrenheit though. So temperature in Fahrenheit, right, we can put it into distinct groups and categories, right? It was this temperature this day, it was that temperature that day, so on and so forth. We can also order it. If it's 80 degrees today, all right, and it's gonna be 84 degrees outside tomorrow, then it's gonna be hotter tomorrow than today, right? So we can logically order those. All right, we also have these meaningful, right, fixed units of measure, all right, with temperature. So that allows us to actually start doing some math, right? Kind of going back to that example I just said a second ago, right? If it's going to be 84 degrees tomorrow and it's 80 degrees today, right, then it's going to be 4 degrees hotter tomorrow, right? We can do that subtraction to get, we can do addition and subtraction with interval scale data, all right, because we have those fixed units of measure. Without them, right, then any addition and subtraction is not going to make sense, right? So even if we do it, it's not going to give us the information that we were actually looking for, right? So that is our interval scale data. All right, now I'm just going to go ahead and do what I've been doing. All right, so the next one is ratio scale data. All right, so I'm just going to kind of tell you what that's all about, and then we're going to contrast interval scale data with that. All right, so ratio scale data, the thing that is distinct about it from interval scale data is that with ratio scale data, we have a meaningful zero value, and we don't have a meaningful zero value with interval scale data. All right, so interval scale data has no meaningful zero value, right? Because of this, we can't make ratios out of our data if it's interval scale, right? So if we're looking at temperature in Fahrenheit, right? If it was 40 degrees today and it's going to be 80 degrees tomorrow, right? Then it's not going to be twice as hot tomorrow as it was today. That's not how temperature works, right? That's not necessarily how that represents, right? We can also think kind of another way, especially with temperature, you think about it is what does 0 degrees Fahrenheit mean, right? Does it mean that there's no temperature, right? That whatever we're measuring with this temperature, your book said, I think it was kinetic energy, right? If that's what we're doing, I'm not a science guy, so I don't know. All right, but if what we're measuring is the amount of kinetic energy, right? Then 0 degrees Fahrenheit does not mean that there's no kinetic energy, right? Doesn't mean that there's no temperature, right? All right, or that there's no heat. Right, so it's just kind of a place, all right? They just place it there, right? You can also compare it to Celsius, right? 0 degrees Fahrenheit and 0 degrees Celsius do not mean the same thing, right? Because they're just kind of placed arbitrarily somewhere, right? Celsius, it's at the boiling point, or excuse me, the freezing point of water. With Fahrenheit, it's, I don't know why they chose to put it there. Again, not a scientist. All right, but all right, we don't have that meaningful zero value, all right? And so, all right, all we can do is kind of the addition and subtraction type math with this stuff. We can't make those ratios. And last but not least, we have ratio scale data. Same properties as interval, right? These continue to build on each other. We can place it into distinct groups and categories. We can logically order that data, right? We have meaningful intervals between our data expressed in the terms of a fixed unit of measure, right? And ratio scale data has a meaningful zero value, right? So this meaningful zero value, again, that's going to allow us to make ratios, right? So let's look at a couple of examples. Right, ratio scale data is very common, right? So here are just a couple of examples. We're not going to get too far into all of them, but so income, height, weight, these are all examples of ratio scale data. All right, we think of income, right? Income, we can definitely do all of those first three things with it. You know, we can put it into distinct groups and categories based on the amount. All right, we can order it. If you have $10 and somebody else has $20, that person has more money than you, right, or a higher income than you, right? And it has those fixed units of measure, right? A $1 change in income is the same whether you are kind of at an income of $14,000 or $140,000, right? A $1 change is going to be the same thing. It's going to mean the same thing, right? And it definitely has a meaningful zero value, right? If my income is zero, that's definitely going to be meaningful to me, right? Height and weight, essentially the same thing. One reason that I want to kind of point these out is because with interval, I kind of mentioned how you look and you compare Celsius and Fahrenheit, and how 0 degrees Fahrenheit and 0 degrees Celsius don't mean the same thing, right? You're not going to find that with ratio scale data, right? So if we're looking at height, whether we're using meters, feet, yards, inches, centimeters, doesn't matter, right? If the height of something is 0, that's the same for any of those units of measure, right? Same with weight, right? If we're using ounces, grams, kilograms, pounds, right? Tons, whatever, 0 is 0 regardless, right? So it does have that meaningful zero value. All right, so when we go about trying to identify what scale of measurement a certain type of data is using, right? One, if you're having trouble with it, this is what I would recommend. All right, so we know that these are all going to build off each other, right? And so what we can do is we can just start, right? We can select some examples, something that we're going to use, right? And then just go through and see if it meets the criteria for the different scales, right? So for example, let's say I'm gonna do, probably should have thought of an example before I got in front of the camera. Let's say all right, let's say that our data is video, the length of this video in seconds, all right? Or minutes, it really doesn't matter, but you know, I just said in seconds. All right, so what we might want to do is we want to go through, right, and check each of these levels of measurement and see if this matches with that. Go ahead and tell you, it's always going to be at least nominal, all right? But this is the way we would do it, right? We would get to nominal, we would say, okay, nominal scale data has to be put into distinct groups and categories, right? Could we do this with this type of data? And the answer is yes, right? We could put this data into distinct groups and categories, right? So check off nominal level data, right? Nominal scale data, and then see, okay, well, does our data meet the conditions for ordinal scale, right? So we already know it can be put into distinct groups and categories. So the next step is ordinal, which is can we logically order it, right? And the answer to that is yes, right? So if we've got a couple of different videos that we're looking at, right, we can order it based on the length of the videos, right? If one video is, 27 seconds long, that is longer than one that's 25 seconds long, right? I bet y'all probably wish these videos were 27 and 25 seconds long, but that's not the case. All right, but anyways, all right, we can order it. All right, it's at least ordinal scale data. All right, then we move to interval. All right, so for interval scale data, we're looking to see if it has that fixed, those meaningful intervals between data expressed in terms of a fixed unit of measure. Right, and in this case, yes, we do. Right, a 1 second difference in video length is the same whether we're at the kind of around 40-minute side or the 45-minute side. Right, it does not matter. 1 second is 1 second. That is a fixed unit of measurement. Right, so it's at least interval. Right, and then finally with ratio, does it have a meaningful zero value? All right, and so a couple of ways we can look at this. All right, if we just think about 0 seconds, what does that mean? All right, especially in this context, if we have a video that's 0 seconds long, it means that we don't have a video, right? Because it has to be longer than 0 seconds for us to actually see it, right? So that is meaningful, right? Another way that we can look at it is by making those ratios. Right, a video that's 60 seconds long is twice as long as one that's 30 seconds long, right? So those ratios actually make sense when we're dealing with ratio scale data, right? And so check that off, and that would be telling us that this is ratio scale data. Right, so essentially when we're using this method, right, whichever one, kind of the farthest one we can get to with a check mark, that's the level of measurement, right? If we had been at nominal and our example, right, what we were looking at couldn't be logically ordered, right, then we would stop there, right, and it would be nominal level data, right? So again, I think this is, I like this way of doing it for a couple of reasons. One, just can give you a guideline rather than just having to look at it and just knowing it, which, you know, is not that difficult, but, you know, especially when you're first starting to do this, right, it's not necessarily going to click immediately, right? Also, this can help you kind of avoid a mistake I see several students making every semester, which is they see kind of they stop too soon, right? If they had been doing this, they would stop too soon because they'd say, well, it meets this criteria, so that means it must be this type of data, right? But we need to remember that these kind of carry through. The characteristics carry through from nominal to ratio. So just because data can be grouped into distinct or placed into distinct groups and categories, right, it does not mean that it is nominal data, right? If it has any of these other qualities, it's not going to be nominal data. It'll only be nominal data if the only thing we can do is put that data into distinct groups and categories. All right, like something, you know, like race, right? We put it into distinct groups and categories, but we can't order that data, all right? And so race/ethnicity would be nominal scale data. All right, so now let's look at a couple other ways of kind of defining and categorizing data. There are two overarching kind of types of data that we're going to kind of categorize in this. So kind of these levels of measurement fall in under these, and those categories are categorical data and quantitative data. Categorical data is also referred to as qualitative data. We're going to use categorical. I think the book uses, let me rephrase that. I'm going to use the term categorical, right? Your book uses qualitative, I believe. I think if you've got two words that are very similar, and you can do one with one letter and one with the other, that's going to be better than both having them have the same letter. Right, so that's what I'm going to use. Feel free to use qualitative, right? If you say something is qualitative rather than categorical, that is still correct. That's gonna be full credit on anything that you have to do that for, right? So feel free to use qualitative, right? But I am going to continue using categorical. All right, so categorical data is data that consists of descriptive information and labels. Right, so it also does not have any naturally occurring numerical values associated with it, right? That's the first time you've probably heard that. All right, so any nominal and ordinal scale data is categorical data, right? So nominal makes sense pretty much because most of the time nominal data is just a word, right? If we're talking about profession, it's going to be, banker. That's the only thing I can think of apparently. No, that's not. Banker, dog walker, right? Used car salesman, whatever it is, right? That's going to be pretty easy. It's a label, it's a descriptor, right? We cannot do math with that. That makes sense. It doesn't have naturally occurring numerical values, right? Ordinal data is the same way, right? We think back to those Likert scales, right? We have numbers with them, and a lot of times those will be kind of presented first, right? But those numbers aren't really what we're looking at, right? Those are just placeholders for those other things, right? Agree, disagree, so on and so forth, right? Those are not naturally occurring numerical values, right? With that ordinal data. All right, so same thing with like, a lot of stuff that pretty much is a Likert scale, but it's not portrayed that way, right? So if you think of kind of anything that kind of follows that same format where it's subjective, where it's opinion based, and you're doing so many things out of whatever, right? That is ostensibly a Likert scale, right? But they don't have the naturally occurring numerical values, right? And we cannot do math with these, right? Really after the next chapter, so after chapter 3, once we get into chapter 4, we're really going to be, for the most part, leaving categorical data behind in this semester, right? It's going to pop up every once in a while, but it's not going to be very common. In this course, because we're focusing on the mathematical side of statistics for the most part. All right, quantitative data. All right, so quantitative data, this is data, right, or measurements that have naturally occurring numerical values associated with them. All right, so any interval or ratio data would be considered quantitative, right? These have naturally occurring numerical values in that they were kind of primed to have numbers placed on them, right? World didn't start with Fahrenheit temperature, but kind of those, again, those units, right, were kind of there, right? The pounds, the degrees, right, what have you, right? Those are kind of naturally occurring, right, and allow us to measure them as such, right? So that is quantitative data. Now, if we have quantitative data, there's a subsection, right, or a subcategory that we have here. So this is for quantitative data only. If we have categorical data, we don't have to worry about this. Alright, so quantitative data is either discrete or continuous. So discrete data, right? If we have discrete data, this is data restricted to a set of values that have data restricted to a set of values that possess gaps, right? So what we mean by this is essentially just that there are some values that the data can take, right, and others that it cannot take, right, because of these gaps. All right, so some examples. One is currency, right? Currency is an example of discrete data. A lot of times, especially when you get into like the thousands and millions and so on and so forth, people will treat it like it's continuous, but technically it's discrete, right? Because there are gaps in the values that currency can take, right? So specifically, let's talk about American currency, right? The lowest value, right, the lowest denomination for American currency is the penny. So there's always at least a 1 penny gap between currency, right? You can go, when you're going from, say, I guess 0 cents to 1, right? There's a jump there. There's a gap, right? There's no half of a cent or a quarter of a cent, so on and so forth, right? You're jumping from 0.010 to 0.01, right? There's no in between there. Another one, I'm not going to write this down because I'm kind of running out of space, but another example of this would be count variables. And so count variables are just variables that you're just counting something, right? How many pets do you own, right? How many cars have you owned, so on and so forth, things like that, right? If we're just counting something, how many customers, use an ATM, right? That is going to be discrete data, right? Because those are going to have gaps. Those are going to possess whole numbers, right? Or at least those examples, you would have whole numbers, right? How many pets have you had? You can't own half a pet, right? Even if you have, a dog that's missing 2 legs, that's still a whole dog, right? It's not part of a dog. So we have those gaps in there. So that's discrete data. All right, and then finally, the last thing we're going to talk about is continuous data. All right, so continuous data is data that can take any value within some interval, within an interval. So this data, we don't have gaps. We don't have those gaps between data. We can take, if there's some range, right, where this variable can kind of have an outcome in, right, it can have any outcome in that range, right? So for example, my favorite example of this is speed. So speed would be a continuous variable, right, or continuous data. So the best way to kind of illustrate this, in my opinion, there are a couple of ways, but so with continuous random variables, right, again, there are no gaps, right, and this is why speed is a good one. All right, so let's say you're going down the road, right? You're driving down the interstate, you're going 65 miles an hour, and you decide to speed up to 66, right? So you don't just kind of, bam, go from 65 to 66, right? You accelerate through all of the possible speeds between 65 and 66 to get there, right? There are no gaps. You're kind of hitting and accelerating through all of those different speeds, right? Related to that, right, if you're looking at your speedometer, right, and it says you're going 65 miles an hour, well, that's not really how fast you're going, right? Most of the time. Well, probably almost always. You're probably going at least a little bit over or a little bit under 65, right? And if you were to get a speedometer with a more precise layout, especially if you have one of the digital ones, right, you could stretch that speed out to an infinite number of decimal places, right? We could always keep getting smaller and smaller and smaller, right? And we don't have those gaps, right? So that is continuous, and that's kind of some of the ways we can think about, well, is this continuous, is it not, right? Can we always get a smaller unit of measure, right? If so, continuous, right? Even if you know we haven't actually named that level of measure, or that scale of measurement, right? Or unit, that's what I was looking for, right? So if you're thinking of like height, right, you can get down to like what, picometers or something like that, right? You can get down to a very small unit of measure, but there's also smaller than that, right? And they might not have named that, but you can keep getting smaller and smaller and smaller and smaller, right? You cannot do that with discrete data, right? With discrete data, you're going to hit a lowest unit of measure, right? Continuous, no, you're not going to do that, right? You're not going to hit that lowest unit of measure, right? Again, also, I'm thinking about, you know, when we go from one unit to the next, right? Are we progressing through a series of values, right? Or are we jumping from one to the next, right? Do we have those gaps versus do we not? All right, but that is continuous data, and that is chapter 2. So in the next chapter, chapter 3, we're going to look at displaying information, kind of, I think it's displaying descriptive statistics is what it's called in the book, or something along those lines. So how do we take some kind of basic information that we might want to show people, right? How do we put that into some kind of display that makes it easier to take in that information? All right, but that's what we have to look forward in the next chapter, and I will see you then.